Hello and welcome to my video explaining everything you need to know about y equals mx plus c kind of stuff. So anything to do with straight lines, basically. Let's start with, say you've got 2 points, let's say it's -1, 4 and 3, 7, I don't know, something like this, and you wanted to find the equation of the line that goes between those 2 points. I would always suggest that you draw a little bit of a sketch first. -1, 4 is like there, and 3, 7 is like there. So we want this line here, -1, 4, 3, 7. Obviously it's not to scale. And we're going to find the gradient by doing rise over step. Now you know some people like to use this formula. What is it? It's like y1 minus y0 equals mx. Yeah, don't use that, okay? I know some revision guides have it in, and some, you know, some teachers might have taught you to use that. I'm not saying that they were wrong, but don't use it. It's stupid. All you need is you need your rise and you need your step, and we can work it out naturally, okay? So how much has it gone across? It's gone from -1 to 3, so it's gone across by 4. How much has it gone up? It's gone from 4 to 7, so it's gone up 3. And you say to yourself, is the line going up? Yes, it is. So it's going to have a positive gradient. So the gradient is going to be rise divided by step, so 3/4 in this case. Okay. And then you know that your equation is going to be y equals 3/4 x plus c. And you need to work out what is the plus c going to be. Okay. And to do that, you're going to substitute into this any point that lies on the line. We have a choice. We have 2 points that we know lie on the line, so we're going to substitute one of those 2 points in. I'm going to go for 3, 7 because it doesn't involve negatives, and I don't like negatives, so 7 is 3/4 of 3 plus c. So 7 equals 9/4 plus c. 7 take away 9/4 will equal c, and you have a calculator, so you don't even have to worry about working that out, but I'm pretty sure it's 19/4. So I didn't even bring my calculator with me, so I'm going to have to do this. Oops, I wrote that wrong already. 3/4 x plus 19/4. Okay. Next thing, finding. Okay, say you've got. They give you an equation like y equals, I don't know, 3x plus 2, and they say find the equation of the line that is perpendicular to this, and it has to pass through, let's say, -1, 2. Okay, so you want the equation of the line that's perpendicular to that and passes through that. Okay, well, if it's perpendicular, then it means the gradient has to be the negative reciprocal of that. So 3 is going to become -1/3. Okay, it's going to become negative because we want the negative reciprocal, and the reciprocal of 3 is 1/3. A quick note on reciprocals: reciprocal of just a number is 1 over the number. The reciprocal of a fraction, you flip it upside down. I mean, technically that's what you're doing with the whole number as well, because 2 is kind of like 2/1. So when you flip it upside down, you're going to get 1/2. The reciprocal of 1/3, flip it upside down, you get 3/1, which is just 3. You can ignore the over 1. Okay, so we get the negative reciprocal. So y equals -1/3 x plus c. We want to know what the plus c is. To do that, we need to substitute in any point that lies on this line. And we're given -1, 2, so we're going to substitute that in. And then we're just going to find out what the c is. So c is 2 1/3 or 7/3, just to make it easier. So y equals -1/3 x plus 7/3. And you can always leave your answer in that form. You don't, unless it says, you know, give your answer in some stupid form like ax plus by equals c. But you know, generally you can leave it as that, and leave it as fractions because there's no reason to convert them to decimals. Okay, what about the lengths of lines? Okay, so what if it says find the length of the line segment that goes from -3, 7 to 4, -9. So I would say draw a quick sketch. -3, 7, let's say it's there, and 4, -9, let's say it's there. It doesn't have to be accurate. Okay, and then we want the length of this line segment. So we're going to kind of do it similar to gradient. We're going to do a rise and a step. So the rise, it goes from 7 down to -9, so that's a 16. And then it goes from -3 to 4, so that's 7. So the length of this line, we can just use Pythagoras. We're going to do 16 squared plus 7 squared and square root it. And we're just going to shove that into a calculator and get the answer. And I'm not really interested in what it is, but that's the method. Okay, but what if it said something like, you've got a line, and it tells you that this point is 2, 7, and it says that this point here is, 6, 15, and it says you've got a point N, which is divides, let's say this is A, this is B. It divides it so that A to N to B is the ratio of 1 to 2, something like this. And you've got to work out where is N on this line segment. So then you can say, okay, well, A to N is 1 and N to B is 2, so N has got to be closer to A than it is to B. So this is one part, and this is 2 parts, okay? So we need to work out a rise and a step sort of thing. From here to here, the step is 4, it goes from 2 to 6, and the rise goes from 7 to 15, which is 8, okay? So if I wanted to split this now so that this triangle is like 1 part, and this triangle is like 2 parts, it's like double this triangle, right? It's like doing this triangle twice. So then you say, well, I've got to make 3 steps in the space of 4. So each of these steps is going to be 4/3, because it's 4 divided by 3. Each of those steps is 4/3. So the x-coordinate of n is going to be 2 plus 4/3, which is 3 1/3. And then looking at the y-coordinates, the whole rise is 8, but it's got to do 3 rises in that space. So each one is going to be 8/3. So from A to N, it's going to go from 7, and it's going to go up by 8/3. So what's 8/3? 2 and 2/3. So it's going to be 9 and 2/3. And if this fraction arithmetic is confusing you, don't worry, you have a calculator. So who cares? Just type in your calculator, you're going to get the answer. You don't need to be able to add fractions anymore. That paper is gone. You can forget all of that, except not really if you're doing A-level maths. You will need to know that. Actually, that's not true. A-level maths doesn't have a non-calculator paper. So we're good. Okay. Next, let's think about where 2 lines meet. So, say you've got 2 lines like y equals 3x minus 4, and usually they'll give you the next one in some dodgy format like this. Something like that. And they'll say, okay, find out where these 2 lines meet. Whenever you're trying to make 2 lines meet on a graph, you are basically solving simultaneous equations. You are saying, where are these 2 thingies equal to each other? Where do these things have the same x and y? To do that, you're going to use substitution or elimination, whatever your favourite method of solving simultaneous equations is. I feel like, I don't know why, I feel like making both of them into a y equals mx plus c kind of format. So I'm just rearranging it. What's that weird noise? Okay, whatever, I don't have time. Right, that's my equation. I'm going to say, where does this equation meet this equation? I'm going to equal them to each other. I have have to make them both in the same format before I can do that. But I'm going to make them equal to each other and I'm going to solve it. So I'm going to add that to there. So I've got 3 2/5 of x equals 4 7/5. What's that? 5 2/5. And let's convert this. So that's 17/5. And that's 25 27/5. Times both sides by 5. And divide. So x gives me that. I just made these equations up off the top of my head, which is why I'm getting horrible answers, but you know what I mean. And then I'm just going to substitute that x into one of these two equations, probably that one because it looks nicer, to get my y. So y equals, we'll get in frame. Okay, y equals 27/17. Do you know how hard it is to write when looking through a viewfinder on your camera? It's actually a lot more difficult than you would think. Also, my hand keeps getting in the way of my view, and you're probably thinking the same thing. And then I would work that out by putting it in my calculator, and I'm not going to do it now because I'll probably get the answer wrong, but that's how you do it. But what if it's not two lines? What if it's a line and a curve? Okay, so what if you had something like, you know, here is a curve and here is a line. Find coordinates where the curve and the line meet. Well, you could have 3 different situations. You could have something like that, where they meet in 2 places. You could have something like this, where you've got a curve and your line only meets it in one place, like it's a tangent. Or you could have a situation where you've got your curve and your line is like over here and it's never going to meet it, in which case you have no solutions. But we can solve all 3 of those kind of things. So let's say your curve is y equals x squared plus 5x minus 3, and your line is y equals 4x plus 7. I really hope these 2 lines are going to meet. Oh well. To make them meet, again, we do the same thing as before. We equal them to each other. They're both in the format of y equals, so we can do that. We can just say, okay, this one is going to equal this one. Notice that this equation is quadratic because it's got a squared in it, which means we're going to have to make it equal to 0. So I'm going to take that away, and end it with that. That's clearly not going to factorise, but you can use the quadratic formula. X equals minus b plus or minus the square root of b squared minus 4 times a times c. And then you shove that into your calculator, and it looks like I got lucky. This one will work, it won't give you a math error. And you're going to get 2 answers for x, because we're in this situation, and then you substitute those 2 answers for x into that to get your 2 answers for y. This kind of thing came up on paper 1, although they didn't say that it was like a curve and a line, they just gave you 2 equations, so I don't know how likely it is you're going to get one like this. Actually, it wasn't like this, was it? It was a circle. And that is basically everything you need to know about y equals mx plus c. I think I have covered everything that I can think of, and I managed to do that in 13 minutes, so I'm pretty pleased with that. Thank you for watching. Let me know if this was helpful, and let me know what topic you would like me to do next, and I'll see you next time. Bye!